Hey guys, welcome back to my channel. We're going to be doing some mechanics today. We're going to go through question 5, part D, from a request from one of my subscribers. Okay, just looking at the question now. So you can see there in this diagram, we have a particle that drops down, and as that comes down, this goes up. Now the particle stops on this plane here. Now obviously the distance that this travels down is the same distance that this travels up. Now when A gets to the ground and that distance has been traveled, there's no more force pushing B up. So we can split the journey into two parts. So this we can call S1, the distance traveled by both particles separately is the same distance. And then once particle A is resting on the ground, particle B continues moving. So I'll use a different color for that. So particle B will then continue moving some distance up. So it's going to go up there, and we'll call that S2. Now the second part of the journey here, we have to be able to recognize the fact that once this force is no longer pushing it up, well actually the ball or the particle is going to slow down until it comes to a stop and then come back down again. Now we're not interested in the downward journey, we just want the upward journey. So except in this case, it's just acting through natural gravitational forces. So it's just going to be, if that's positive, we can say it's moving up with an acceleration of negative 9.8. The initial velocity is going to be the final velocity of S1. We'll get to that. Final velocity is going to be 0 because then it's going to come back down again. And S2 is just the distance traveled. You've been told a few things in the diagram and the question. First of all, the acceleration for part 1 is a quarter g, and the time traveled is 1.2 seconds. So we're going to use that information. First thing we're going to do is find the distance traveled for S. We're going to find S1. So write your typical SUVAT, S-U-V-A-T. We know the time is 1.2. The acceleration is a quarter g. The initial velocity is going to be 0 because it starts from rest. Final velocity we don't know, and distance traveled is just S1. So then we can use S equals ut plus half at squared. Now u is 0, so it's just 0 times 1.2 plus half. Acceleration is a quarter g, so a quarter times g squared. So t is 1.2 squared. You can simplify that. That comes out to 0.18 g. Obviously, as a final answer, you'd turn that into a decimal into 1.764 meters, but we're going to leave it like this just to keep accurate. So I'm going to put 0.18 g meters. Now we need to find the final velocity for this so that we can find the initial velocity for S2. So this is just, again, using SUVAT equations. We can say v squared equals u squared plus 2as. U is 0, so that's just 0 squared plus 2 times a quarter g times s, which is 1.2. And this comes out to be 0.3 g. Again, you would turn it to a decimal, and what it actually means is 2.94 meters per second. So I'll just round that. But we're going to use 0.3 g just to be more accurate. So the second part, what we want to do is find the greatest height achieved. So we know that the first distance traveled is 0.18 g meters. The second part of this journey, we're just going to do SUVAT again. So SUVAT. Now this time's acceleration is negative 9.8. The time we don't know. We know the final velocity is when it gets to the top, so that's going to be 0. The initial velocity is going to be the final velocity from the previous part, so that's going to be 0.3 g. So you can put that there. And s is just s2, so second distance. From here, we want to find s, so we just do v squared equals u squared plus 2as. Now you know that v is 0 squared is 0.3 g squared plus 2 times negative 9.8, and s is s2, we don't know what that is. Rearrange this, you get 19.6 s2 is equal to 0.09 g squared, and then you divide both sides by 19.6. Put that in a calculator. You have to square the whole thing, and you get 0.441 meters. So then this is the distance traveled for the red part of the journey here. So we found S2 and you found S1 from part 1, so then you just add them together. So it's going to be 0.18 g plus, and then in this case it's 0.441. Now, this is the tricky part of the question, which students will forget, is actually asking you the greatest height above the plane. I think it's a bit tricky that they're asking you that. I don't know what is testing there. So we actually need to add this distance twice. So we figured out this distance traveled, so then we also need to add another 0.18 g. Put that all in a calculator, turn g into 9.8, and then you end up with your final answer, which is 3.969, which is roughly 4 meters. Okay, I hope that was useful. Smash that like button, hit subscribe, and I'll see you for some more content later on.